Hello student, good morning. Now I am going to discuss quantum mechanical model of atom. Actually, what is this quantum mechanical model of atom? Try to understand. This is a very important concept, and regarding atomic structure, this is the final concept. Now I am telling you. Classical mechanics based on Newton's law of motion successfully described the motion of all macroscopic objects, macro MAC, big particles, macroscopic objects such as a falling stone, orbiting planets, etc., which have essentially a particle-like behavior. However, it fails when applied to microscopic objects, micro MIC, objects like electrons, atoms, molecules, etc. This is mainly because of the fact that classical mechanics ignores the concept of dual behavior of matter, especially for subatomic particles, and the uncertainty principle. Actually, classical mechanics, they have ignored dual behavior and uncertainty principle. The branch of science that takes into account the dual behavior of matter is called quantum mechanics. Again, I am repeating, the branch of science that takes into account this dual behavior of matter is called quantum mechanics. Quantum mechanics is theoretical science that deals with the study of the motion of the macroscopic objects that have both observable wave-like and particle-like properties. It considers both particles-like behavior and wave-like behaviors. It specifies the laws of motion that these objects obey. Actually, this theory specifies the laws of motion that these objects obey. That law they follow. When quantum mechanics is applied to macro MAC, macro objectives for which wave-like properties are insignificant, not important. When quantum mechanics is applied in macroscopic objects for which wave-like properties are insignificant, the results are the same as those from the classical mechanics. Again, try to understand. When quantum mechanics is applied to macro MAC, macro big, when quantum mechanics is applied to macroscopic objects, the results are the same as those from the classical mechanics. Quantum mechanics was developed independently in 1926 by Werner Heisenberg and Erwin Escrowdinger. Here, however, we will be discussing the quantum mechanics, which is based on the idea of wave motion. The fundamental equation of quantum mechanics was developed by Schrodinger, and it won and it won the Nobel Prize in Physics in 1933. This equation which incorporates wave particles duality of matter as proposed by de Broglie is quite complex, and knowledge of higher mathematical is needed to solve it. For a system such as an atom or a molecule whose energy does not change with time, we will consider this point. For a system such as an atom or a molecule whose energy does not change with time, the Schrodinger equation is written as very simple way I am telling you. It is represented as capital H bar psi. Psi actually it is represented like just like a Trishul of Lord Shiva. That Trishul like that one symbol is there, that is called psi. And capital H bar like symbol is there, capital H psi. Then H here, H is a mathematical called operator. Here H is a mathematical operator called Hamiltonian. Then here one equation is there in a brief, very simplified way. Actually its derivation is separate. It takes too much time. But finally it comes like that. H psi I told you, just like its representation is just like a Trishul of Lord Shiva, like that representation is there. Then H psi is equal to E psi, capital E psi. This is the very simplified form of Escrowdinger wave equation. Here I want to tell you I will little idea I will give you that what is a Schrodinger wave equation. Actually a Schrodinger wave equation is it is represented by, that is the del square psi divided by dx square plus del square psi divided by dy square or dy square plus del square psi divided by del z square, or d also you can tell. That is equal to minus 4 pi square m square divided by h square into 2 upon m in bracket e minus v outside psi. E is the total energy. V is potential energy. Actually here both energy is required, kinetic energy and potential energy. Energy has two parts, kinetic energy and potential energy. Then after solving this equation, it comes del square psi divided by del x square plus del square y plus del y square plus del square psi divided by del z square plus 8 pi square m divided by h square in bracket e minus v outside psi, that is equal to 0. Then here after this step finally I am telling you they have made very short. This del square psi divided by del x square plus del square psi divided by del y square plus del square psi divided by del z square. This is considered as delta square, just like a triangle, delta square. and then now equation became short, and finally H, that is the mathematical operator, Hamiltonian operator H, capital H, that is equal to minus h bar square divided by 2m and delta square plus v. Then here this term Hamiltonian operator means Hamiltonian operator is equal to minus h bar square divided by 2m delta square plus v. Then simplified portion, what I told you now, it came, that is the h psi is equal to E psi. H psi is equal to E psi after simplification, and that I will give you one sheet of this formula. I will attach in the distance in the video. Then this h psi is equal to E psi, that is very simplified, you can say, form of Schrodinger wave equation. And here I told you, I want to tell you, here we are using three term x, y, z. X, y, z. Actually, we know that electrons moves. In an atom, electrons moves. Then where will it move? It is not fixed. It may move in three direction, three coordinates. It can move in three coordinates. Maybe in x direction, maybe in y direction, maybe in z direction. Hence all three direction has been considered, because electrons are in wave nature, and it can move in any direction. That's why all three direction coordinates has been considered. That's why the term x, y and z, x direction, y direction, z direction has been considered. And also we know that electron may have two type of energy, kinetic energy and potential energy. That's why both energy has been considered. Then finally, after considering all the things, and one more things, I told you these things, Hamiltonian operator H. Question is asking, I ask what is the Hamiltonian operator, then you should tell Hamiltonian operator is equal to h bar square divided by 2m delta square plus v, and delta square is equal to del square divided by del x square plus del square divided by del y square plus del square divided by del z square. This is the important part of the Escrowdinger wave equation. Then here again one more thing I want to tell you. Here this things h, what is the actually h bar? Then h bar is equal to h upon 2 pi. That it has been made shortcut. Planck constant divided by 2 pi, that is called h bar. Now I have in a brief I have told about the little things about the derivation, and derivation is not required for lower classes, it is for higher classes only, honors and MSc it is derived. Okay, but I have given here, I told you somewhat idea. Then how, because h psi is equal to E psi, that is the simplified, very simplified form of Schrodinger wave equation. Now I want to tell about the psi. I want to give the idea about the psi. Why it is this psi? What does it means? Then actually this psi letter, just I told you, just like these things, Trishul, like Trishul, this presentation is there. Actually it is just like a presentation, psi or psi. Then what does it mean? Why we are using in this equation psi? Then actually this psi will tell, clearly understand. Also student gets confused You people should not get confused. Psi means psi will tell all information about the electron, where electron is there, in which orbital electron is there, many orbitals are there. In an atom, many orbitals are possible. Then where electron is there, all information about the electron is given by the psi. After solving the equation, after solving the complicated equation, you will get all idea about the electron information, where it is there from the nucleus, how far it is there, what it has energy, what is the R value, means radius, all information regarding electron. Who will tell? Then psi will tell. Psi means you can understand like that. Just example I am giving you. Suppose you gone to purchase any apartment, then one person will be there. You can get inquiry from that person about the whole, you can say, apartment. Like that type of situation is there for psi. Psi will tell details about the electronic position, electronic velocity, electron's energy, radius, how far it is from the nucleus. All things you can know by the these things. By the, you can say, the word psi term, psi symbol indicates all the things. This is the very, very important when you are studying the Schrodinger wave equation. Now I told you full concept of this. Now I am going ahead. Then here I told you that H psi is equal to E psi, that is the Schrodinger equation, very simplified way, where H bar is a, just like above the H, arrow sign will be there, little slightly arrow like symbol, that is called H bar, mathematical operator. H bar is called mathematical operator called Hamiltonian. Schrodinger gave a recipe. Hamiltonian gave a recipe of constructing the operator, constructing this operator from the expression for the total energy of the system. Total energy of the system. The total energy of the system takes into account the kinetic energy of all the subatomic particles like electrons, nucleus, etc. You know that opposite charge attraction is there. In opposite charge attraction is there, and the same charge repulsion is there. The total energy of the system takes into account the kinetic energies of all the subatomic particles like electrons, nuclei. Attractive potential between the electrons and nuclei, and repulsive potential among the electrons and nuclei individually. It will take into account all the things. You know that nucleus has positive charge, electron has negative charge, then attractive force will work. If you can say only electron you will consider, then repulsive force will be there. That opposite charge, nucleus, positive charge, electron, negative charge, then attraction will be there, attractive force will be there. If suppose many atoms are there, then many nucleus will be there, then that time nucleus will be, repulsion will be there. And if so many electrons are there, then among themselves electron repulsion will be there. Then in deriving this equation, all things has been considered. Attractive force, repulsive force of subatomic particles has been considered. Okay. And if this equation, what I told, Schrodinger wave equation, when it was solved, then solution of this equation gives a E value. E means energy value, energy of electron, capital E. It gives the value of energy of electron, and psi. Psi means after solving, psi will tell all information about the electron. This I have told you in general way about the Schrodinger wave equation. And Schrodinger wave equation, just it follows dual behavior of, you can say, particle, dual behavior of particle as well as dual behavior of light. That's why it is this equation, this form, this model, which tells what weakness was there in all, you can say, theory, all model, that this model, quantum mechanical model, all the quantum mechanical model of atom solved the all or cleared all the doubts of the previous many models given by many scientists. Now it is general. Now I am focusing on particularly for hydrogen atom, a Schrodinger equation for hydrogen atom and the Schrodinger equation. Actually, from this many question is asked, but it will come under the toughest question, because actually it is just introduced for the lower classes, and depth studies in the BSc honors and in master degree. Generally, a question is asked in master degree, BSc honors and CSIR examination, question is asked. But here, if people for lower classes, that some things, basic idea, the question they will ask, which will tell basic idea of Schrodinger wave equation. Okay. Anyhow, listen, it will be helpful. And here I want to tell you only questions from this type of topic. If any students will solve, then their chances will be more to qualify in any competitive examination, because generally a student want to escape, but those students who will not escape, who will answer, then some question, if they will answer, their possibilities to compete in examination will increase. Okay. Then now I am discussing hydrogen atom and the Schrodinger equation. When a Schrodinger equation is solved for hydrogen atom, actually it can be solved for multi-electron, you can say, atom also, but here we are focusing only for hydrogen atom or hydrogen-like atom. When a Schrodinger equation is solved for hydrogen atom, the solution gives the possible energy levels, just like orbit, energy levels the electron can occupy, and the corresponding wave function, function or functions also you can tell, psi. Correct? After the solution, it will give the value of energy, and it will give the value of wave function. Psi is called wave function. Correct? Psi is called wave function. Don't forget. Wave function of the electron associated with each energy level. Here again I want to tell you, this psi, which is called wave functions, that is related to each energy level. Suppose 4-5 energy levels are there, then for each energy psi value will be there. Okay. suppose 3 orbits are there, 3 energy levels are there, then 3 type of this will be there. Psi value will have 3 value, 3 type of value will have. That is called wave function. Psi is called wave functions of the electron associated with each energy level. These quantized energy states and corresponding wave function, which are characterized by a set of 3 quantum numbers. Again you listen, important things I am telling you. These actually I told you these energy levels are quantized, that is also called energy states. They are quantized, fixed energy. This quantized energy state and corresponding wave function, which are characterized by a set of 3 quantum numbers. What are the 3 quantum numbers? Then principal quantum number, that is represented by a small n. Azimuthal quantum number, which is represented by L, a small l, and magnetic quantum number, a small m. Here again I want to tell you, actually there are 4 quantum number, not only 3, 4 are also there. Fourth is called a spin quantum number. A spin quantum number. Then what is actually quantum number? Actually I will discuss how to know the details about the quantum number, but here I want to brief you what is actually quantum numbers. Quantum number, listen carefully, quantum number is an address to locate an electron in an atom. You know that electron will be in atom only. Then where actually it is there? Then these quantum numbers are an address to find the electron in an atom. It is just like your address. New person will come to meet you. You will give address. Then that person will come and meet you. 2, 3 address means it will be there. Your address will be maybe big. Just like any person comes from the foreign to meet you. Then first they will come to India, means Delhi. After that from there they will come direct to suppose you are in Bangalore, then Bangalore they will come. After that your where you are living, that district they will come. After that they will block, they will come. Then their village will come. Then 4, 5 steps are there. Like that way, here if you want to know that in an atom where is electron, then there is a address to locate an electron in atom. Then that address is called quantum numbers. Okay. Now I am going ahead. That 3 quantum numbers like principal quantum number n, azimuthal quantum number L, and magnetic quantum number m arise as a natural consequence in the solution of the Escrowdinger equation. If you will solve the Escrowdinger equation, then these 3 terms comes. 4th terms comes and the end spin quantum number, that is their concept is different, because suppose now I am giving example. Suppose now your guest has come, just entered in your house. Then suppose there are 2 rooms. Then now they will think you are in which room. We have only suppose 2 rooms. Then where you are, in this room or that room. Like that way, this electron finally it will be in the actually orbital. Then in the orbital 2 only can say in any orbital only 2 electrons. Only 2 electrons will be in the orbital, and one here what I want to tell you, electron will be always in movement, just clockwise and anti-clockwise. Just like in cricket ball, cricketer they will spin the ball. Like that way here electrons spins in two directions, clockwise or anti-clockwise. Then for that purpose a spin quantum number has been given. Its value is given plus half minus half. Clockwise if they will move then plus half, anti-clockwise it will move then minus half. For this due to this movement this spin quantum number has been given. Okay, now actually I have briefed you all the things. Again I will come in details because its calculation is there. You have to calculate value of L, M, N, all things. Then I will discuss in details. Now I want to go ahead. When an electron is in any energy state, the wave function corresponding to that energy state contains all information. Again I am telling you, the wave function corresponding to that energy state, the wave function corresponding to the energy state contains all information about the electron. The wave function is a mathematical function whose value depends upon the coordinates, x coordinates, y coordinates, z coordinates. I mean three directions is there now, that has been considered, whose value, psi value, depends upon the coordinates of the electron in the atom and does not carry any physical meaning. Such wave functions of hydrogen or hydrogen-like species with one electron are called atomic orbitals. This is very, very important things I am telling you. You can say wave function of hydrogen or hydrogen-like species with one electron are called atomic orbitals. Such wave function pertaining to one electron species are called one electron system. Actually orbital, I am telling you what is the orbital. Then I told you electrons will be moving, always will be moving. Where it is, that is very difficult to tell. Then probability in three-dimensional space, probability of finding an electron in three-dimensional space where there is a maximum probability of finding an electron, that space is called orbital. That space in three-dimensional space in an atom where there is a maximum probability of finding an electron, that space is called, that room is called orbital. Okay, you should not confuse. These very, very important things I told you. And there are different type of orbitals. Just like in an apartment, you have purchased apartment, then many rooms are there. Many rooms may be there. Then in which room orbitals, which room electrons are there? Actually three-dimensional space, I told you. In atom, three-dimensional space where there is a maximum probability of finding electron, that space, that room is called, where electron will be there, that electron probability, always probability, not granted, not certainty, that place, that space is called orbital. Okay, this I cleared the what is the atomic orbitals. Such wave functions means psi pertaining in one electron. Such wave function pertaining to one electron species are called one electron system. The probability of finding an electron at a point within an atom is proportional to the psi square. Actually only psi has not too much meaning, but psi square is meaningful. It tells about the probability of finding an electron in three-dimensional space. Psi square is meaningful. Psi square is equal to 1. Keep in mind, that 1 marks question they can ask. Psi square is equal to 1. Okay, that is it came from the solution. Then probability of finding electron at a point within an atom is proportional to the psi square at that point. The quantum mechanical results of hydrogen atom successfully predict all aspects of the hydrogen atom spectrum, including some phenomena that could not be explained by Bohr's model. Now I am going ahead. Application use. Application of Schrodinger equation to multi-electron atoms. Now I am talking about the multi-electron. Multi-electron atom presents a difficulty. It is not so easy. Presents a difficulty. The Schrodinger equation cannot be solved exactly for a multi-electron atom. Again limitation is, you can see for a Schrodinger equation. A Schrodinger equation cannot be solved exactly for a multi-electron atom, but for one electron it can be solved very easily. That also is solved, but with great difficulty is there. This difficulty can be overcome by using approximate method, because exact you can't know, then approximate you can use. Here actually I want to tell you, in a master degree it is derived, all things are derived actually, and it is very very long, you can say, derivation. It may go 6 to 7 pages. Then you can understand how much time it takes and how is a full, you can say, very difficult and depth, because now you are knowing very simple one for S orbital, P orbital, D orbital, F orbital, you are directly knowing the result. But how did it come? How did it come that you have to derive it? From the derivation you will get all the things, their shape, size of different orbitals. Then it is a depth studies done only BSc honors onward in MSc, and many question is asked only at higher level. For lower level it will be only their basic things will be asked. Derivation is complicated, difficult, okay, particularly for multi-electrons, multi-electrons atom. Then application of Schrodinger equation to multi-electron atoms present a difficulty. The Schrodinger equation cannot be solved exactly for multi-electron atom. This difficulty can be overcome by using approximate methods. Such calculation with the aid of modern computers show that orbitals in atoms other than hydrogen do not differ in a radical way from the hydrogen orbitals. What we have discussed now, that for multi also same things are there. By recent method, by using computer, all thing is done, then it is found that even for the multi also, multi-electron atom and hydrogen atom, not too much difference is there. Similarity is there. The principal difference, what are the main difference between multi and single electron like hydrogen? What is the main difference that I am telling you? Hydrogen atom and multi-electron atom. What are the difference? Because hydrogen means only one electron. Multi-electron atom, what are the different, that I am going to tell. The principal difference lies in the consequence of increased nuclear charges. If a multi-electron nuclear charge will be more, it will increase. Because of this, all the orbitals are somewhat contracted. Contraction will be there. Compression will become small due to the attraction of electrons and nucleus. They will come close to each other, very close to each other. That is the difference. Because of This all the orbitals are somewhat contracted due to the attraction. Further, we know that sub-electrons, unlike orbitals of hydrogen, not like, unlike orbitals of hydrogen or hydrogen-like species. Hydrogen-like species also comes under the single electron like hydrogen only, not multi. Hydrogen-like species, unlike orbitals of hydrogen or hydrogen-like species whose energies depend only on the quantum number n. Principal quantum number n for energy, this will give idea n, a small n, number of orbit n, that will give idea about the energy of that energy state. Energies depends only on the quantum number n, principal quantum number. The energy of the orbitals in multi-electron atoms depends on quantum number n and l. This is the difference, that in one hydrogen, in hydrogen atom, energy depends only on n, but in multi-electrons atom, energy depends upon n and l, means azimuthal quantum number, principal quantum number and azimuthal quantum number. This is the only difference. This question is asked. Okay, it comes under the difficult question. Now I just want to just tell about the, this is again very important things I am going to tell. Important feature of the quantum mechanical model of the atom. This is the full, you can say, brief of the quantum mechanical model of atom. Brief, 5 points are there, I will tell you. First point is that the energy of electron in atom is quantized. Already I told you, that is, can only have certain specific value. For example, when electrons are bound to the nucleus in atom, electrons are bound to the nucleus in atom. The energy of electron, I told you, the energy of electron in atom is quantized, means fixed. This is the first point. Second point, the existence of quantized electronic energy level is a direct result of the wave-like properties of electron and are allowed solutions of Schrodinger wave equation. Correct? This is the second point. Means the existence of quantized electronic energy level. How it became quantized, means fixed, then that is the consequence of, you can say, wave-like properties. It came by the concept of wave-like properties. That's why it became quantized. And allowed solutions of, it was allowed solutions of Schrodinger wave equation, means it came quantized, it became quantized. That is due to the, after solution, it came to know that energy of electron is quantized, means energy level is quantized. Okay, this is the second. Third, I am telling you, both exact position and exact velocity, means I am talking Heisenberg uncertainty principle, I am talking about. Both the exact position and exact velocity of an electron in an atom cannot be determined simultaneously. This is the third, actually, these things. Third point of, you can say, mechanical model of atom. The path of an electron in an atom, therefore, can never be determined or known accurately. Correct? Because position and Position and velocities both are not fixed. That's why the path of an electron in an atom therefore can never be determined or known accurately. Means what Bohr's told that is a well defined path, that is not correct. Now fourth point I am telling you, and but here under the third you can tell, exact you can't tell, but probability you can tell. Probability you can tell that where will we only probability, you can tell only probability of finding the electron at different points in an atom, that can be predicted, that can be told. Now fourth point, an atomic orbital is the wave function psi for an electron in an atom. Again you listen carefully. Fourth point, an atomic orbital is the wave function psi for an electron in an atom. This is the wave function. Atomic orbital is the wave function. Keep in mind, whenever an electron is described by a wave function, we say that the electron occupies that orbital, that particular orbital. Since many such wave functions are possible, many wave function means many orbitals. Since many such wave functions are possible for an electron, there are many atomic orbitals in an atom. These one electron orbital wave function or orbital form the basis of electronic structure of atom. Here again important things are there. The one electron orbital wave function or orbitals, due to these orbitals, what happened? These orbitals form the basis of electronic structure of the atom. In each orbital, the electrons has a definite energy. An orbital cannot contain more than 2 electrons, what I have told you. In a multi-electron atom, if number of electrons are more, then what will happen? In a multi-electron atom, the electrons are filled in various orbitals in the order of increasing energy. First electron will go in the less energy, then higher energy, then higher energy, then higher energy, like that. They will fill according to the increasing energy. For each electrons of a multi-electron atom, there shall therefore be an orbital wave function characteristics of the orbitals it occupies. Actually, for each electron of a multi-electron atom, there shall be an orbital wave function characteristics of the orbital it occupies. All the information about the electron in an atom is stored in its orbital wave function psi. I told you. And all information you will get by solution of psi. After solving this psi, all information are stored in the, you can say, wave function psi, and quantum mechanics makes it possible to extract this information out of psi. And after the solution means I told you that after solving this psi, the quantum mechanics makes a possibility. It become possible to extract this information out of psi. And last point I am going to discuss, the probability of finding an electron at a point within an atom is proportional to the square of the orbital wave function that is the psi square. Already in the beginning I told you at that point. Psi square is known as probability density. Psi square is also known as probability density and is always a positive value. From the value of psi square at different points within an atom, it is possible to predict the region, means a space, predict the region around the nucleus where electrons will most probably be found. Correct? Then only probability you can know where electron is there, exact value you can't know. Heisenberg uncertainty principle told, if position will know, velocity, momentum will change. If momentum will know, velocity, this position will change. Hence only probability is there. You can find out the probability of density where electron may be. Then now I have finished these things. This quantum mechanical model of the atom, all things I have told you. Now I will go, next class I will go in details about the orbitals and quantum number. Full question is asked, many questions are asked from this topic. I will discuss in the next class. Okay, thank you.